A meter ruler has a mass of 1.2 newtons. There is a force of 1.8 newtons at the 90 centimeter mark. Find the point at which the ruler will balance. Pause the video now and have a go at this question. As usual, a very sensible first step is to draw a diagram of the situation. So we have a meter ruler, which is obviously 100 centimeters long, or 1.0 meters. It is a uniform distribution of mass because it's a meter ruler, which means at the 50 centimeter mark, there will be its center of mass, which is a force of 1.2 newtons. And there is also a force of 1.8 newtons at the 90 centimeter mark. It says find the point at which the ruler will balance. The ruler will balance at somewhere between here, and we don't know where that is. So there's going to be some distance here, which I'm going to label D1, and some distance here, which I'm going to label D2. So let's use our principle of moments to see where we can get, because at the point that it balances, we know that the sum of the clockwise moments will equal the sum of the anti-clockwise moments. So we can say that 1.2 newtons times by distance 1 is going to be equal to 1.8 newtons times by our distance 2. Now, you'll probably immediately notice that this is not any use. We've got one equation, we've got two unknowns, so this is not helpful at all. But we can start to simplify this situation a bit more. We know that the distance between the 2 points is 90 minus 50 is 40 centimeters. So what we can say is we can write D1 in terms of D2 or the other way around. So I'm going to call this D1, and I'm going to say that this distance here is going to be 40 centimeters minus D1. So what I'm going to say is 1.2 newtons times by distance 1 is 1.8 newtons times by 40 minus D1. Now I've got one equation and one unknown. So we can start to solve this equation. So I'm going to start by just multiplying out the brackets, D1, and then I can say 3D1 is 1.8 times 40. Which is 72. So therefore distance 1 is 72 divided by 3, which is 24 centimeters. Now this is not the full answer because we're saying distance 1 is 24 centimeters, and we know that the center of mass is at 50. So the point at which it will balance is going to be 24 plus 50, which is 74 centimeters.